Hi, this is Mrs. Lemke, and we're here today to kick off unit number 4 of our class. And in this unit, in this lesson today, we're going to be learning what a polynomial is, as well as how to add, subtract, and multiply polynomials. You might notice in this list that division is missing. Division is a more complicated case, and so that's saved for its own topic. I would like to remind you that video lessons are really only effective if you are participating. So make sure that rather than just listening ahead and seeing me work out a question, whenever you are prompted to do so, you should pause the video and try problems on your own, because that will really help you to learn the topic yourself. So please remember that that is the design of things. Hopefully you also are listening to this, not just writing things down without any audio or with using closed caption only. Really, the sound and the visual together are what make this as effective as possible. All right, so following through on your notes, there are just a few definition type things that we're going to be looking at in terms of what a polynomial is. It's important for you to understand this because polynomials actually are the overall topic of our new unit. So this is kind of a big deal here for us to get a good solid footing. Okay, so a polynomial is something that has two or more terms to it. Terms are separated by addition or subtraction. So polynomial has multiple terms. Let's write that down. Technically could actually also have one term. To be honest, I was thinking about the prefix poly meaning multiple. So I'll include or just one, because we will include that case. Especially when what you're doing here is you're like adding or subtracting terms that have different powers of the same variable. So adding or subtracting pieces or terms. I know I have to go back and explain what a term is. So adding or subtracting terms that have different powers of a variable. Okay, so this is what I would say. These two things are really important, and a third point that I would make is just that terms are separated with addition or subtraction. Okay, so maybe that definition doesn't make the most sense. I actually struggle with this as a definition every time I have to teach it, but I think by showing you examples and counterexamples, it will become more clear. Okay, so let's take a look at exactly that. Okay, so something that would be a polynomial would be things like the quadratics we've recently studied. So if I had something like x squared plus 6x plus 7, that is a polynomial. These addition signs that I have here separate the terms. So this particular example has 3 terms. Do you understand now what I mean by a term? Okay. I also could have other powers, not just x squared. So I might have something that goes to a much, what we would call higher degree. There's another vocab term I just threw in there. Okay, so this is something that has, think about it. How many terms does this have? If you said 4 in your head, that is exactly right. Okay, all these addition and subtraction signs are the separators between terms. So this guy would have 4 terms. And the degree that we would say it has is also 4, but because of this 4, not because of how many terms it has. Whereas in the previous problem, we would say that that has degree 2. Because of this x squared being the largest exponent on an x. Okay, so we have the idea there of terms, and we have the idea of degree. I'm going to give you a little side challenge here. I would like you to write a polynomial in your examples there. Give me something that is degree 5, and it has 3 terms. Okay, see if you can write down an example that has both of those qualities. Okay, please pause the video. Give yourself the time that you need to write a polynomial of degree 5 with 3 terms. Okay, here's an example. Clearly yours is going to be different, but to check your work, you would just make sure if you were to add or circle the addition and subtraction signs, in between those, you'd have 1, 2, 3 chunks or terms. And if you look at the exponents on your variable, for example, I have x to the first, x to the second, and x to the fifth. The largest such exponent should be a 5. Okay, and that makes it degree 5. All right, so hopefully we have a handle on what things are polynomials. Now let's talk about things that are not. So something that we have seen this year that is not a polynomial would be if I had an equation that had a radical in it. So if I have something that has x inside of a square root, that's not a polynomial. Now you technically could have a number inside of a square root, just to make things nice and confusing, folks. Okay, so this up here, where I have square root of 7 times x squared plus x, that would be a polynomial. But what makes the example that I'm looking at down here not a polynomial is having a variable in a root. So we could make a note about that. Variable in root. It is something you can have in math. It just isn't called a polynomial. That's called a radical function, right? You have your variable inside a radical or a root, okay? So that's math. It's not a polynomial. Another thing that you would see in math, but you wouldn't call it a polynomial, is if you had something like this, okay? So the bottom on its own would be a polynomial. So if I just had x squared minus 4, that is a polynomial. However, if that x squared minus 4 is in a division problem, remember that a line like this means division. Okay, that's a division sign. I can't write. So a fraction bar is a division sign, right? So if we see division, right, with dividing by an x, that's not a polynomial. It is something in math, it just isn't a polynomial. This is actually called a rational function, which we will study later this year, okay? And then this other one we said was called a radical function. Okay, so they are math ideas, they're just not of this unit. Okay, so we can't have divided by an x, we can't have a square root or any other kind of root with an x inside of it. Those would not be polynomials, okay? Another thing that you cannot have would be negative exponents. Again, this is something that exists in mathematics. It's just not in this category, okay? So no x to a negative power. Okay, those are things that are not polynomials. All right, so when we do have polynomials, adding and subtracting is just combining like terms. And something that is useful in terms of combining like terms is if you have subtraction, I would recommend that you change that to adding opposites. And if you have multiplication, you are going to just think about distributing. Okay, so I know that on your notes it says examples, but rather than put examples right there, I'm going to go to the next part of your notes and pull examples from this part. okay? So the first three questions, they find the sum or difference. Sum means addition, difference means subtraction. Okay, that's all that means. So in question 1, it's an addition problem. Addition is literally just combining like terms. So like terms means those that are alike, such as both of these terms have an x squared. Both of these terms have just an x to the first. And both of these terms have no x at all. They're just constants. Okay, so that's what we're going to combine. Okay, we're going to combine like terms. So let's do that. So when I look at the x squared terms, I say, well, I have negative 4 plus negative 1. That makes negative 5. So I have negative 5x squared. When I look at just the x to the first, I have negative 6 plus positive 7. So that makes positive 1x squared. You can write a 1 here if that makes you feel more comfortable. If that's confusing, don't write that. And then we have 18 and we have 8. So we're just going to combine like terms and have 26. So my answer is negative 5x squared plus x plus 26. You can see in your notes packet that I do have answers included there. Those answers don't include the work though, so we still need to make sure that we are doing the full problem. If I were to see on your paper that you just have answers for certain problems of this, I know that you did not work them out because they do require multiple steps. Okay, so just answers, that's not adequate. Question 2 and question 3 are both subtraction problems. And with the subtraction problems, remember that my advice to you was that you should switch it so it's adding opposites. So what I mean by that is I'm going to take this middle subtraction sign, I'm going to change it to addition, and then every sign that follows that is going to reverse. So this first sign is going to become a positive, this one's going to become negative, and this one on the 63 is going to become positive. At that point, you now have made it into a question like problem 1, where all you have to do is combine like terms. So for instance, 6x squared plus positive x squared is 7x squared. Then I'm going to go to the plain x's, and I'm going to say, well, I have negative 12 plus negative 24x, so that would be negative 36x. And then for my constants, I have 48 plus 63. I do have to think about that a little bit, but that's 111. Okay, now question 3 is longer, but it is not more difficult. It is merely longer. So we're going to take the subtraction sign in the middle. We're going to make that adding, and then we're going to take every sign that follows that subtraction and make it opposite. So this would be adding, this would be negative, this would be positive, this would be negative. Okay, I want you to pause the video and remember that all you're doing is combining like terms. So we're going to look for things that have the same exponent. If we find nothing, like with the negative x cubed, you're adding it to 0. So negative x cubed plus 0 is still going to be negative x cubed. And for the other things, just combine like terms. Okay, please pause and come back when you have completed the problem yourself. Okay, this is what you should have for number 3. Take a minute and verify that you have every term of this written completely correct, including the signs. Okay, at this point, if you're having a difficult time with adding or subtracting, or you feel confused, pause the video and ask your teacher for help. All right, there are 6 more problems at the bottom of the page. I'm going to do 3 of them with you. Please note that the directions here say find the product. Find the product means that you are multiplying. Okay, a product is the result of a multiplication problem. In problem 4, we have a single term. That single term would be called a monomial. Okay, so this whole polynomial on its own just has one term. There's no adding or subtracting another term with it. And so we're just going to distribute that monomial to every term in the 4-term polynomial that it's being multiplied by. So we just follow those green arrows. 2x squared times 2x to the 3rd. So 2 times 2 is 4. And then x squared times x to the 3rd is x to the 5th. If we need to reason through that, remember that x squared means you have x times x. And x to the 3rd means you have x times x times x. So if you multiply those by one another, sorry, I'm having a little bit of issues. Don't make fun of me, Covey. Then you have x squared times x times x times x. That's going to be an x to the 5th. So when you're multiplying, it's a little bit less restrictive than when you're adding. When you're adding or subtracting, you have to have exactly all like terms we call that, okay? When you're multiplying, you're just taking 2 times 2 times x times x times x times x times x in this case. All of those bits together make what I wrote in red. Okay, now we take 2x squared, which is 2 times x, and we multiply by another x times x. This has a negative sign. Okay, so with that, we would have minus 2, and then this all makes x to the 4th. We now take 2x squared times 3x. That's 6x to the 3rd. And then 2x squared times negative 5 is negative 10x squared. So this multicolored thing I have here is my answer. In question 6, we have 3 binomials. So notice I said the word binomial. That's when you have 2 terms. So I have 2 terms here, then I have 2 terms here, and then I have 2 terms here. So I have 3 binomials to multiply together. When I have 3 things, like just think about regular math, 2 times 3 times 7. I don't take 2 times 3 and 2 times 7. That's not how that goes. You take 2 times 3 and you get 6, and then you take that answer times the thing that you didn't deal with yet. Okay? And that's how you get your answer of 42. This is the same idea here. You can pick any 2 to put together first. Let's say we do those 2 first. Then we distribute the way we talked about before. You could write it like that, or you could write it using the memory tool, first, outer, inner, last, right? But the idea is each of those pieces gets multiplied to each of the other pieces. That's distributing, okay? So let's go ahead and whatever way you want to do it, make sure that every piece of this binomial gets multiplied by every piece of that binomial. That's the key. Okay, when you do that, you should get x squared minus 2x plus x minus 2. The order of those terms might be different. If you think about it in a different order, that's fine. We would combine like terms. And now we're ready to multiply by the one that I have in blue. Okay, I like to take the thing that has fewer terms and distribute that. I think that's easier to think about. So I'm going to take this x and multiply by each piece of the red. And then I'm going to take the 6 and multiply that 6 times each piece of the red. Then I'm going to take this line that is written in black and in purple and look and see if I have any like terms to combine. So nothing else has x to the 3rd. These are both x to the 2nd terms. These are both x to the 1st terms. And then I have that 12 at the end. Okay, so take a look at that. If you're confused, ask for help. Definitely ask for help. The last example that I'm going to do with you is not more difficult, but it is honestly quite long. Okay, so let's just take a look at how this goes. I have something with 3 terms. That's called a trinomial. Okay, so that I could just call it a general polynomial, but specifically it has 3 terms. And this term, or this polynomial, also has 3 terms. So I need to do each of these 3 pieces is going to go with each of the other ones, right? There are 3 pieces in both places. So I'm going to show you a vertical way of lining this up, and you might like this and you might not. If you're fine just saying I'm going to distribute these, and then I'm going to distribute the negative 10x squared, and then I'm going to distribute the 25, and you're fine with that, this might not be for you. But for some of my students in the past, they kind of liked setting this up vertically. And it's because you can deal with combining like terms at the same time as doing the multiplication that some of my students in the past kind of liked this. Okay, so I actually didn't think ahead very well on this. So let me rewrite this for a quick second. Hold on, I'm just going to move it over to the right. Okay, so I'm going to start now with taking this -1 and multiplying it to each of these 3 terms above it. So -1 times 25 is -25. -1 times -10x squared is positive 10x squared. And notice I wrote positive as a plus. -1 times x to the 4th is going to be negative x to the 4th. Okay? Then I'm going to take this next term on the bottom and I'm going to multiply it to each of the terms above it. So I'm going to do -6 times 25, -6 times -10x squared, and -6 times x to the 4th. I invite you to pause at this point, come back in a quick sec when you have that next line figured out. What you're going to do is write your answers in the next row of work, just right underneath, but at the same time match up the like terms. If nothing matches, write it off to the side. Okay, so I don't think my directions were super clear, so I apologize. I should have just had you work with me. So the red -6x multiplied to each of those 3 things above gives you this result in red, and you can see that I have to the 5th, to the 3rd, and to the 1st. None of those combines very well with what I have previously, so I did not line anything up. Okay, now, if you don't know what I mean, just stick with me. See this next step, and it'll help you a little bit. Okay, we're going to take the part I put a green box around, and we're going to multiply it to all 3 pieces up above. So 3x squared times 25. 3 times 25 is 75, and I'd have x squared. So I'm going to line that up here. So I'd have 75x squared. I lined it up because the x squared matched my previous x squared. Then 3x squared times -10x squared would be -30x to the 4th. So that I'm going to line up right here. And I forgot to write a positive in front of that 75, so I'll do that real quick. Then I have 3x squared times x to the 4th. And that will actually give me 3x to the 6th, and I don't have an x to the 6th, so I'm just going to squeak that out at the end. Now I'm going to write a big line, and I am now looking at this in a vertical sense. So I'm looking for things like here and here, where like terms combine. So I would have, all told, 3x to the 6th minus 6x to the 5th plus 60x to the 3rd minus 150x. Now we're to the very exciting part that is highlighted. -1x to the 4th and -30x to the 4th add to -31x to the 4th. And 10x squared plus 75x squared would make 85x squared. Then I also have 25. being subtracted. Now, I could put this in order. You will usually see this in answer keys. Usually you'd have the x to the 6th term, then the x to the 5th term, then the x to the 4th term, so that would be over here. Then the x to the 3rd, then the x to the 2nd, so that would be over here, right? Then the x to the 1st, then the number. So usually we go in descending order from largest to smallest on the exponents, but honestly, that's not super important. I would say it's not important at all. If you got to this line of writing, we would be thrilled, okay? Now, there are more practice problems there, and you know that you have the answers, but here is showing the work, right? Showing the steps in between. So I'm going to just leave this screen up for a little bit. You could pause the video and then don't look at it for a minute. Just kind of like push it off to the side and do your work on 7, 8, and 9 if you'd like some more practice. If you feel you've got it, that's great. You might not necessarily need to do more practice, but let's pause now in case you do want to practice more. And that would give you the opportunity to check against this part where the work is shown, not just the answers. Okay, in any case, whether you did these last three problems for additional practice or not, I would like you now to turn to your assignment and get started on that. Remember to ask for help if you're confused, and thank you for listening.